Welcome to Homework Lib.
Hi, so for all of this question, essentially the things that we are going to use is that pH is minus the logarithm of concentration of H plus or hydronium ion. pOH is going to be minus logarithm of concentration of OH minus. We know also that pH plus pOH needs to be equal to 14, and the same relationships go for pKa and pKb. In water at least. And the operator P in front of anything, it's simply taking minus logarithm of that quantity. So for example, pKa will be minus logarithm of the Ka. Okay? So you can convert one to another. If you're given the pKa, we can find the Ka as 10 to the minus value for pKa directly. Okay? So let's begin with all of the possible questions that we have. The first one, we have a base that has a Kb of 1.17 times 10 to the minus 6. What is the pKb? We are just going to take the minus logarithm of that, right? And the result is 5.93. The next one, we have an acid. We are given the pKa, and this is 1.836 times 10 to the 0. So we can find the Ka as, I'm going to ditch the scientific notation just for the sake of clarity, 10 to the minus 1.836. 1.836. Oh, sorry. So, yeah. This result, and this is going to be 1.46. Well, to keep the same amount of significant figures that we are using, 1.459 times 10 to the minus 2 molar concentration. Sorry, times 10 to the minus 2 directly. I got a little bit ahead with the concentration of H plus and so on. So this would be the value for Ka. Next up for question 3. Um, we have a base with pKb equal 3.413. What is the pKa of the conjugate acid? Well, for this we're going to use pKa plus pKb needs to be equal to 14. Thus, pKa is 14 minus pKb, that is 3.413. Thus, pKa is equal to 10.587. Okay, next question. 4. A certain acid has a pKa of, I'm going to ditch the scientific notation just to avoid confusions, but you can add it directly. The pKa is 9.586. What is the acid's Ka? As we said, Ka is going to be 10 to the minus pKa, so 10 to the minus 9.586. And the result is 2.594 times 10 to the minus 10. That is going to be our value for Ka. Next question. Now we are dealing with concentrations of OH minus. So we're given the concentration of hydroxide ion, which turns out to be 4.432 times 10 to the minus 9. molar, we need to convert it to POH, right? We simply take the minus logarithm of that quantity, which is going to have a POH of 8.35. Um, Next up. Ta-ta-ta. The next one, we have the pH of an aqueous solution at 25 degrees Celsius, and we are told that the pH is equal to 1.143 times 10 to the 1, right? So the pH is 11.43. What is the concentration of hydrogen ion? And the same thing goes with the concentration of hydronium with the pH. It's the same thing as with the pKa. It's 10 to the minus that value. Okay? So the value is going to be 3.70 3.715 times 10 to the minus 12 molar. In this case, I can use molar concentration, right? Because this comes from the concentration value. And the final one, uh, 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 the final one is going to be, we are given the concentration of OH minus is 9.171 times 10 to the minus 3. What is the value for POH? Remember, again, minus logarithm of that concentration, which is 2.03. 2. Actually 04, rounding up. And that would be all.